Today we are studying pressure measuring devices. The most common pressure measuring device is a pressure gauge, Borden pressure gauge. So in Borden pressure gauge, inside this there is an elliptical tube. I'll explain you again with this cut section. So one end of that elliptical tube is connected to the pressure tapping, and that is connected to the location where fluid pressure is to be measured. Inside this there is an elliptical tube, so the fluid flows through the elliptical tube. The other end of the tube is free end. So when high pressure liquid is supplied, high pressure or low pressure liquid is supplied, that free end tries to unwind, and that motion of the free end is connected to this pointer using a mechanism. So this is pressure gauge. To gauge means to measure. So when it is exposed to atmosphere, it shows zero reading, means it is atmospheric pressure, that is there is no difference between this, the zero difference indicates pressure is atmospheric. So this gauge measures system pressure above atmospheric or below atmospheric. When the pressure of system is above atmospheric, the pointer rotates in clockwise direction and we get that reading. And if the pressure is below atmospheric, this pointer moves in anti-clockwise direction. So this is commonly used device known as Borden pressure gauge. Now this Borden pressure gauge, we are connecting here two tappings. So this is one tapping and this is the other pressure tapping. So the fluid is flowing, a pump is circulating the fluid, and the pressure tappings are at two locations. And now you can see this pressure gauge reading indicating pressure difference between the 2 points. You can see this reading. U-tube manometer, simple U-tube manometer. So this U-tube manometer, there are two limbs, left hand side limb, right hand side limb, and there is a scale. So the scale is used for measurement of level differences. A fluid is placed in these U-tubes. The fluid used in this manometer is known as manometric fluid, and its density should be higher than the density of fluid whose pressure is to be measured. So these are pressure tappings. If a system pressure is to be measured, this is open to the atmosphere, so the atmospheric air enters through this limb and atmospheric pressure acts on the liquid on the right hand side limb, and the left hand side pressure tapping is connected to the system whose pressure is to be measured. So if the system pressure is above atmospheric pressure, that fluid forces this liquid in the manometer downwards, so there is drop in manometric fluid level and the manometric fluid rises in the right hand side and we get a level difference. So that level difference is measure of pressure. If the system pressure is below atmospheric pressure, it means that the air which is present above this liquid column on right hand side limb of manometer is atmospheric, whereas the pressure acting on the fluid in left hand side is below atmospheric. So this air forces this fluid in right hand side to move in downward direction, and this fluid in the left hand side limb rises and we get level difference, and that level difference, using that level difference we can calculate system pressure. This is one more type. Compared with U-tube manometer, this inclined tube manometer is sensitive. Note that there are two limbs, one inclined and one vertical, and the diameter of this inclined limb in which the liquid rises or falls, the diameter of this is far lesser than this tube diameter. Now this tube is inclined, so this angle, if we know this angle, then we can change this length into vertical height using this angle. So this, compared with a vertical scale or vertical manometric fluid column, the rise or drop of manometric fluid in this inclined tube this length is more than the vertical distance. So it is more sensitive. Now this is an air blower used for increasing pressure of air slightly. So this a blower gives out high pressure air. It is flowing through this pipe, and there are two pressure tappings in the pipe through which air is flowing. So these pipes are connected to this inclined tube manometer using these flexible pipes, and depending upon the pressure, we get rise or fall in this column depending upon the pressure difference between the two pressure tappings or two locations. So you can see that this means that pressure is increasing, or if pressure reduces, we get this movement of manometric fluid in the inclined limb. This is one more type. This is known as single limb manometer. So again you can see the two limbs. So this right hand side limb, diameter of this is far greater than this. So this is known as a reservoir. We are measuring here the rise and fall of manometric fluid only in left hand side, whose diameter is far lesser than this. So when these pressure tappings are connected to the locations where pressure or pressure differences are to be measured, the rise or fall in manometric fluid is noted, and as the diameters are, there is significant difference in diameters, the fall or rise in this reservoir we can neglect it. So this is single limb manometer, and you can see the rise, significant rise in this left hand side, and very negligible drop of fluid in the right hand side, that is reservoir side. This is another type of manometer, inverted U-tube manometer. So this manometer is used for measurement of very small pressure differences. The pressure tappings are connected to the locations where across which we require pressure difference, and that is comparatively smaller pressure difference. So in this case, the fluid is generally present here, and above that air is present. There is provision for removing air or supplying air. So as the pressure at the two locations, one is at higher pressure side, other is at lower pressure side, we get rise in manometric fluid in left hand side or right hand side, rise or fall of manometric fluid on left hand side or right hand side depending upon the locations where pressure is higher or lower.